Okay, so we were discussing about stresses, and in the last class we were discussing about stress transformation from one coordinate system to another coordinate system. Now, here this is x and y coordinate system, and we have a data of stresses in terms of sigma x, sigma y, or rather you can write sigma x axis, sigma y y, and shear x y. So, this you can write. Now, if we transpose from one coordinate system to the another coordinate system, we are willing to find out the stress sigma x dash dash, sigma y dash dash, and shear x dash y dash. So, I am looking for this. For that, what we did, we just draw a block. So, let us say this is a block. This side is experience sigma xx. It is experienced by sigma yy and also sigma yx, shear xy, yx, sorry. So, if I am making like that, then probably you can complete this diagram by adding these arrows. Okay, so now this is the complete diagram for that. And then what we did, we wish to find out the stress along this direction, and this direction is x dash. So, for that what we have made? We have made a perpendicular line to that, and this line we are joining from this point. So, it is like that. So, its normal is x in a x dash direction. So, actually we are dividing this complete block into two parts. This is block means part of 1, this is part 2. Now, if you look at this line normal is oriented towards x dash direction. Now, you can start dividing this block from this point also. यहाँ से भी आप कर सकते हैं. You can divide from here also. From here also you can divide from here, anywhere, but the result will be same. For making simple, we are making from the vertex of this. Now, our objective is just to find out the stress along x dash direction. So, we have divided into two. Now, we will take this part only, block 1. Now, this is block 1, and this block is experience the stress like that. This is block 1. Probably you know yx and xy nomenclature. Here we are considering shear yx is equal to shear xy, and both are positive. It is moving from this point, this is 0 0 axis. If it is moving in a positive x direction, If it is moving in a positive y direction, then we will consider positive. Okay. So now this is the net force, this is the force which is applied on this block, part of this block. So we have to ultimately find out what will be the force in x direction, what will be the force in y direction. And here we are considering this length, let us say this is A, this is B, it's C, D and E. So now this point is A, here it is E and it is D. So we are considering length of AE is equal to 1. You may consider anything. So if it is 1, then whatever will be the force in x direction, so force divided by area, or in 2 dimension force divided by length is termed as traction force. So we will specify this force in this direction divided by area as Tx, and this will be Ty. So ultimately our goal is to find out on line segment of A which is having unit length Tx and Ty. Now if you look at this block, it is having a theta degree, or this is normal direction, this is also having a theta degree. Now go to the previous one. Now here this block is having, means this is the block and this block is having a force in x direction sigma xx, shear yx, both are oriented both are oriented in x direction. So we will just find out, these are the stress. First we will calculate what will be the force in this direction, x direction. So for that what we will do, we should have a length of AD. AD is nothing but the cos theta, because this is theta, and this segment will be sin theta, as we discussed in the previous class. So ultimately Tx is nothing but sigma x cos theta. This is the force in x direction with respect to sigma x axis. You all know that force by length or area is equal to stress. So force will be stress multiplied by length in 2 dimension. So stress value is sigma x axis, length is AD. AD is nothing but cos theta, because we have considered this AE is equal to 1. So this length would be cos theta, this DE would be sin theta. So that is why you can write sigma x cos theta. Similarly yx, you just remember I am writing yx, because yx means shear force is applied in x direction, and it has to be multiplied by sin theta, because this length A is, now this block AE is having, DE is having a length of sin theta. So stress, shear stress multiplied by length is equal to force. So this force is also applied in x direction. So altogether this is Tx. Similarly we have written in the last class Ty, and this Ty is equal to shear xy. Again you note down, xy means force is applied in y direction. It has to be multiplied by sine component. Look at here, this shear xy is applied on this, so it has to be multiplied with cos theta. Let me erase this. Cos theta plus shear y. Now both the forces, sigma yy is also in a positive y direction, shear xy is also in positive direction. So both are additive. So shear yy, so sigma yy multiplied by this segment, that is sine segment, sine theta. Length of this d is sine theta. So it has to be multiplied by sine theta. Okay. So now these two things we have evaluated. Now we wish to find out the stress in normal direction, not in x and y. So what we have to do? We have to take the component, because this Tx and Ty are the vector force. So it can be resolved. So Tx cos theta would be in normal direction. We wish to find out the force in normal direction divided by area, termed as stress in normal direction. So what we will do? We will just find out, we will just calculate the force in normal direction. So force in normal direction is equal to Tx cos theta plus this is Ty, its normal component means force in this direction would be Ty sin theta. So let us calculate this. Tx we will take from equation number 1, Ty from equation number 2. So Tx is nothing but sigma xx. Sometime I am using xx, sometime I am using only x, both are same. So I am just replacing Tx from equation number 1. So this is Tx multiplied by cos theta plus Ty. Multiplied by sin theta. Now just rearranging these, I can have this expression. Now you can look at this expression. Am I audible? Okay, so after rearranging this, I can write sigma xx cos square theta plus sigma yy sine square theta plus, now here there are two components, shear yx and shear xy. If you look at the previous slide, as per our sign convention, we are considering shear yx and shear xy because both are orienting, these force are orienting in positive y direction with respect to x, 0 0. So we are considering both are equal. So as per our sign convention, both are equal. So now what we can do, because both are equal, so we do prefer sigma xy rather than yx. If it is in a 3 dimension, then we would prefer xy, yz and zx. So anyway, now I can rearrange this equation like that. So this is nothing but the force in normal direction. Now look at this, AE, this is the force in n direction. So force divided by length or area in 3 dimension is nothing but the stress. So now what I can say, this Fn I can write like that, sigma n means normal stress. So here our normal direction is x dash direction. So I can write sigma x dash is equal to stress x cos square theta plus stress y sin square theta plus 2 shear stress sin theta cos theta. Now can I rearrange this into a different form? If you recall, there are now this is the expression. If you recall the trigonometrical functions, then you may find that cos square theta is equal to 1 plus cos 2 theta divided by 2. Similarly, sin square theta is nothing but 1 minus cos 2 theta divided by 2. And of course, 2 sin theta cos theta is equal to sin 2 theta. So if you implement, if you use these two expressions, now we can arrange sigma x dash is equal to sin x sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 theta plus shear xy sin 2 theta. Okay. Any doubt? Now we wish to calculate the shear stress. Now again we will look here. As I told you, there are two blocks, block 1 and block 2. What actually we have evaluated, calculated? We have calculated what will be the force, net force, or what will be the force normal to this. means along the x dash direction. Or this force is applied on block number 2. So, whatever we have calculated, this force is applied this is block number 2. Whatever we have calculated, it is applied normal to. So, as I told you, if the force is towards the body, now this is the body, if the so this force is try to compress the body, it means you are getting the compressive stress. And this is also obvious also, if you are compressing this block from sigma x, sigma y, shear x y, then you will have a compressive stress along this. So, the purpose of this force is to compress the body. Now, another is we just find out what will be the force, because we have calculated the normal force, we have to calculate the shear force also. So, where it will be applied? Shear force will be applied in this direction, normal force will be applied in this direction. So, if this is the block divided into 2, force because of block number 1 is applied on 2. Similarly, forces from block number 2 is applied on block number 1, then only both the blocks are under equilibrium condition. So far we have calculated the force because of 1 applied on 2, this we have calculated. So, what actually we did? Let us take a small piece of this. I am just taking a square block. We have calculated what will be the force in this direction so far. Now, we are willing to calculate the force in this direction, shear, on this particular block, block number 2. Is block number 2, now this is a very small part. So, what will be the force in this direction? We have already told you, this is nothing but stress sigma x dash x dash. Now, we are willing to find out the stress in this direction, and because this is creating the shear force, so we will represent by shear tau. If this is x dash, as I told you, 90 degree in a counterclockwise direction would be y dash. So, as far as notation is concerned, this force is oriented towards y dash direction, and this plane where it is applied is x dash, normal to that is x dash. So, this shear will be called as shear x dash y dash. So, now we have to calculate the shear force along this direction based on this equation. So, of course, we have calculated Tx and Ty, and this is theta degree. Similarly, this is also theta degree. So, Ty sin theta, sorry, Ty cos theta is the component here. Tx is along this direction, इसका हमें sin component चाहिए, but it is in the negative y direction, y dash direction. So, positive y dash direction minus negative y dash direction is, it will be the net. So, what will be the function? Ty cos Tx sin. So can I write like that? Traction force in shear direction would be Ty cos theta minus, why it is minus? Because this traction in x direction is, its component is in negative y dash direction, that is why so this is the expression. So Ty, what is the value of Ty, and Tx I can take from here. Now Tx is, first we will consider Ty, shear Yx cos theta Ty cos theta minus Tx sin theta. I am arranging on the new page. Now Tx is nothing but sigma x cos theta plus shear x Yx sin theta, and Ty is equal to shear xy cos theta shear y sin theta. Okay, putting these equation here, sorry, so I think this is all clear. So replacing Ty from this equation, shear xy cos theta plus shear sigma yy sin theta cos component minus stress xx cos theta, I am taking Tx function from here. So ultimately we will have this expression. After rearranging this, I can write so now this is the expression for force in shear direction. As I told you that the plane length is 1, so if you divide by the length, then it comes as a shear stress, and where it is applied? It is applied on x dash plane, and the direction of force is y dash. So this is the expression. Okay, so again This is cos theta sin theta. You all know that 2 sin theta cos theta is equal to sin 2 theta. Similarly, cos square theta minus sin square theta is also cos 2 theta. So, after rearranging this expression becomes sigma xx sigma yy by 2 . So, now this is the expression of shear x dash y dash. Right. So, if you look at both the expressions, this is for shear, this is for normal. Now, if you look closely, then you can find that this is an expression of, it may be an expression of circle. So, first I have to rewrite it to understand the things. Sorry. I am again rewriting it. Okay, so now there are two things. Now this is equation number, you can say equation number 1, now this is equation number 2. Now if you look at closely, then we can graphically rearrange this expression. And how it can be done? Let's say I am making an axis where I have to make this y axis as a shear component, x axis as a normal component. Now I can express these expression within this circle. This we can do. So afterward we will discuss this thing, but first we will try to calculate what will be the maximum value of sigma x dash, because this is a function and this function is having a variable of sigma x, sigma y, theta and shear xy. And if you look at the thing, sigma x, sigma y and shear is the stress value at a particular point with respect to xy coordinate system. Now, what will be the value, maximum value of sigma x dash y dash? So, if you change the angle, then probably you will get the different values, because it is in a function. So it must have some maximum value, it must have some minimum value. So what will be the maximum value? So to get the maximum value, what we have to do? We have to differentiate it with respect to theta, and if you make it 0, then you will find at particular theta it will have either the maximum value or the minimum value. Okay, so for that, this is a constant term independent of theta. Now this is the term. Now cos 2 theta. So what will, if you differentiate it with respect to theta, then what will be the value? 2 बाहर आ जाएगा. So 2 cos what will be the value? Cos 2 theta. Okay, so our function is so this is the function. Now if you differentiate it with respect to this is the constant term, so 2 cos का है माइनस साइन, इफ आई एम नॉट रॉन्ग. Sine will be minus sine. So now you can write, and this must be equal to 0 for getting the maximum or minimum value. So now what you can do, you can arrange sine 2 theta by cos 2 theta is equal to, you just shift this component in a right side. Okay, so now this become so at an angle of this, or this is nothing but tan 2 theta. So tan 2 theta will be like that. At this particular point, either the normal stress or stress in x dash direction will be either maximum or a minimum. So this is an angle. Okay, now come to this previous page. Now how we can, as I told you that this is, we can arrange this expression into a circle. So let us try to attempt. Now I can say that uh, how I can arrange this. If I am putting sigma x dash, sorry, sigma x and sigma y in normal direction or normal axis and shear xy in y direction. So, okay, so let's say this is a value of, so what I am doing, I am just making a graph. So, here I may consider one grid block is 1 MPa, let us take, or 0.1 MPa or 2 MPa, something like that. So, this is the scale and this is nothing but the 0, 0. So, based on this, I am just putting 2 points, sigma x, sigma y. Let us say sigma x is equal to 2 MPa, sigma y is equal to 5 MPa and shear xy is equal to 1 MPa. So, plus 2 means it is a compressive stress in x direction, plus 5 compressive stress in y direction. Shear xy positive means if you try to make this graph, it will be like that. 2 I am representing with this arrow, 5 with this arrow, and shear xy is equal to 1 positive. It means the shear force will be acting like that. So, this is the body diagram. Now, stress in x direction is equal to 2. So, let us say this is 2, this is 5 and shear xy is equal to 1. So, now this is, it is referring x point, now this is referring y point. So, xy 1 means positive. So, I am just making a line, its length is 1 meter, this length is 1 meter. So, opposite to that I am making here, this is also 1, then just take a diagonal where it is intercept here. So, this will be the center of the circle and this is the radius AOB. So, AO is nothing but the radius of this circle. Now, you just make a circle. Now, here you can see that this center point, this point is nothing but sigma x, this point is nothing but sigma y, and what will be the center? Center will be sigma x plus sigma y by 2. So, this is the center. Center of the circle. Okay. Now, come to this part. A, B, C, let us say this is C, this point. AC is the shear. So, now this is the shear component. And what is that? Sigma x minus sigma y by 2. Sigma x, sigma y by 2 means half of this. You can say this is the radius, oh sorry, this is this segment CO. So, this is nothing but CO. So, if I wish to find out the maximum value, then what will be the value? The value will be, first you have to find out the center. What is the center? And center is nothing but sigma x plus sigma y by 2. And then you have to find out the radius. So how do you find out this radius? OE. If you know OD, OD is the sigma x minus sigma y by 2. This is the radius. DB is the shear. So square of this plus square of this, take the under root, then this will be from the Pythagoras. You can find out the radius. You just add it. So you can get the maximum value of this function. So this now the thing is, where is sigma x dash? X dash. So let me just draw a bigger one. Okay, so this was representing sigma x and this was representing y axis is shear. So now this coordinate is known as, it has to be referred like that. And opposite to that side is referred as sigma yy, shear yx. Now here shear yx seems, because it is in a negative direction, so it seems like a negative value, but as per as our convention, we were considering sigma x, shear xy is equal to shear yx. This we were considering, means both will be of same nature and equal magnitude, but here it seems like negative. If we are considering positive axis is positive, negative axis is negative, then this coordinate would certainly be negative. So that is why I told you that there are two system of sign convention. If you are looking for the rotational system, then certainly it will be like that. Shear xy is equal to minus of yx. If you are considering that as we discussed, then shear xy is equal to shear yx. So if you are looking, if you are calculating the things based on the circle, and this circle is, its name is Mohr circle. They actually, this Mohr actually identify that these two equations can be rearranged in the form of circle. So here we will consider, because this is related with x, so now this is considered to be a x axis from here to O, and this is considered to be a y axis. So now this is x axis from O to this point, A point is x axis, O to B point is y axis. Now what we are doing in our case, we are finding out x stress in x dash direction. So x dash direction is making theta degree counterclockwise with respect to x axis. So here if you look at this expression or that expression, here you are finding that it is having a 2 theta concept. You can convert into a theta also. So, if you look at this expression, then what you have to do, if I consider that this is 2 theta, if it is 2 theta and I am moving from x axis, I am moving from x axis to x dash axis by 2 theta in a clockwise direction, then this value, this point which is intersecting circle is nothing but x dash and shear x dash y dash, and this will be the y. So, ultimately we have to find out this value from 0 0 to this length. What is this length? Is nothing but, so if you go back by this expression, if you consider this expression, then you will certainly find out that at this particular point the sigma x dash value will be like that. So, that is why we can say that you can rearrange this into a circle. So, in the next class we will discuss in detail whether it is fulfilling the circle equation or not. So, this is for today's class. We discuss means how to calculate the stress in different coordinate system. This is called as stress transformation, and it can be rearranged into this. So, what you have to do at this particular point, maximum value you can find out now. Maximum value where? To shear x y by this, or alternatively you can rewrite this shear x y divided by 2. So, now shear x minus shear y by 2 is nothing but this gap from here to here. So, this divided by this, shear y x divided by this component. Now, this component is nothing but shear x y, and this component is nothing but sigma x minus sigma y by 2. So, at this particular point you will get the maximum value or a minimum value. So, in the next class we will discuss more on Mohr circle.